All right. We're going to do 1.9.3 vertical asymptotes. What we did, and I can't remember exactly what section it was. I think 1.4 or 1.3 maybe. We discussed how you make a rational expression be undefined. So we talked about making a rational expression undefined, and what that meant was that we were going to take the denominator and we were going to set it equal to 0. So I have this entire thing equals 0, and what this actually is three parts. You have A times B times C. There's three different expressions with an x value with a variable, and they're all multiplying. So I'm going to have x equals 0, x plus 4, which is simplified, x plus 4 equals 0, subtract 4, you have x equals -4. All right, so you have x equals 0, x equals -4, and then you have x minus 8 equals 0, and you add 8, you get x equals 8. So what we just did, we found the values in which this rational expression would be undefined. All right, now what that means is we just created vertical asymptotes. So I come over here, I'm going to draw a graph. I'm going to go ahead and choose here, and then see how good of a graph I can draw now. Follow a straight line, and it most certainly could be worse, so no need to make fun of me. Oh, that's not that good. That's close enough. All right, so I draw a graph, and we determine x equals 0, -4, and 8. So 0, so x equals 0 is right there. X equals -4, 1, 2, 3, 4. And then x equals positive 8. So 1, 2, 4, 5, 6, 7, 8. And what this actually is, so at these points are vertical asymptotes. And on apex, most vertical asymptotes are denoted by vertical red lines that go through these points. I apologize, this just isn't that good. All right, so what we have is 3 vertical asymptotes. And what that means is these are the values in which the rational expression is undefined. They are the values where the graph doesn't exist. So that I don't know the exact graph, so it looks something though. It's just, I'll give you an example real quick. It may look something like this. It will get really, really close to the red line, but it won't touch. Here it could even be here. You go here and then down to there. And I'm just making this up. This graph could be completely different. I'm not totally sure. It could go like this, right? It gets close to the red line, but never actually touches. Goes right up next to it. Again, same idea. It gets close, but never actually gets there. So it'd be getting closer as you go down this way. So what an asymptote is basically it's a dead spot in the graph. It's a spot in the graph that doesn't exist. It just doesn't make sense. And the graph can't touch or cross it. So he ends up having like multiple graphs kind of broken up to form these. And again, this may not be accurate to the problem that we just had. But that's the key. And then if I come back and I get a graph that has this, I guess I'll make one more. So say I have here, and I make that my 0, and they'll give you a graph and say and what'll actually be is there'll be some version of an actual real graph built in here. I'm just drawing asymptotes. So these red vertical lines represent asymptotes. So these are the spots where the graph does not touch, it doesn't exist. 1, 2, 3, 4, 5, 6. So you have x equals 6 there. 7, 8, 9, 10, 11, 17, I think. X equals -5. X equals -16. So when we have to go the opposite way. When you're given a graph and you're given the vertical asymptotes, you have to go back and you have to make the graph. Well, what does that look like? So there'll be something on top. There'll be something on top. Right? We'll just put this. This represents whatever that may be. Whatever this is, there's something on top. Then on the bottom, I have x equals -16. So what I'm going to go ahead and do, I'm going to say this is x plus 16. X equals -5. This is going to be x plus 5. I'm always going to go opposites. X equals 6. So I know what my denominator has to have a x minus 6. And we have x equals 17. It's going to be x minus 17. All right. Again, as always, reach out to me if you ever need any help. So don't if this doesn't work for you, always reach out. That's for everything. But when we're given the graph with the red vertical asymptotes and we identify where on the x-axis they are, if I have a +6, I need to have a x minus 6 factor. So these would be considered your vertical asymptotes. You kind of go opposite to get them into the equation. If that makes sense. It's always going to be kind of split and opposite.